Okay, so we're on page 104, and we're going to take a look at something called point slope form for a line. In the last couple weeks, I've mentioned pretty frequently the work I saw on your pretest for this unit. We all did slope pretty well, so I'm not worried about that. Or we struggled with this, so we're going to talk about it a little more. Most people were okay with slope intercept form, which I talked about last week, writing slope intercept form or using slope intercept form, but point slope form was kind of hit or miss. So I'm going to talk about point slope form like you've never seen it. You very likely have all seen it, but how much you used it kind of depends on maybe what your middle school teacher's personal preference was. So that's why it might be really familiar for some of us and kind of fuzzy for others. Okay, so that's what we're going to take a look at today. But before we actually start using point slope form, I want to do a quick review of what we saw with slope intercept form. So for slope intercept, remember that's the one that looks like y equals mx plus b. M is our slope and b is our y-intercept. So if you want to write an equation in slope-intercept form, you need to know the slope and you need to know the y-intercept. You have to have those two pieces of information. Today, we're going to look at something called point slope form. And it looks like this, y equals m, and then in parentheses, x minus h plus k. So m is still the slope. You still need to know the slope. But for point slope form, you don't need to know the y-intercept. Any point on the graph will work. And that's where h and k come from. So h and k are the x and y values for some point that's on the line. So it opens up our options a little bit. If I don't have the y-intercept, that's fine. We can still write point slope form. And this is what we're going to focus on for today, point slope form. So for our first example on page 104, I'm starting with an equation. I want you to notice that this looks an awful lot like the transformation stuff that we worked on in Unit 2 and then earlier in Unit 3 as well. So if I asked you what transformations from the parent function do I see here, you would look at the 1/2 and say, well, I compressed this. I kind of smashed it down a little bit. And I shifted it to the right 3 places, and then I moved it down 2 spots, right? Point slope is, again, something that we've seen before, but in that context of transformation. So if I'm talking about what's the point and the slope that I've got here, well, the slope would be this guy here. We've sort of transitioned talking about that lead coefficient as the slope for our function. So we know our slope is 1/2. And then to find our point, we're going to use these pieces of information. Just for this first one, I want to show you how we can get that from the transformation. So this is telling me, remember for our parent function, we started at 0, 0. This is telling me move to the right 3, 1, 2, 3, and then down 2. And that's where my point lands. So I'm at 3, -2. Same values that we had in here. The only tricky part, just like with transformations, -3 is going to move us to the right 3. So if I see minus a number, it's actually going to be opposite sign here. So whatever's in parentheses with x opposite sign as your x, and then whatever's at the end is your y value. So there's a point that we get from our function. And then the slope, remember, is rise over run. That's our set of directions to get more points on this graph. So here's a point that I have already. And then this is telling me go up 1, forward 2. Remember, I always want at least 3 points on any graph that you give me. I'm out of space this way, but I can reverse those directions and find some points back here. So down 1, back 2, down 1, back 2, down, back to. Always at least 3 points. And then since we're graphing a function, don't forget to connect your points and throw those arrows on the end. There's our graph. So we can represent a linear function with an equation, with a graph, or with a table. And we've seen these three options before. We haven't used point slope form yet in this unit, but we did this with slope intercept, equation, graph, and table. Now, I want to remind you, if you get stuck graphing, you get a quiz in front of you and you forget what all of these numbers stand for, I don't remember any of this, I forgot how to graph, what can you do? You can always make a table. Yeah, you can always graph by making a table. So if you get your point slope form in front of you or slope intercept or whatever in front of you and it just falls out of your brain, I don't remember what to do, make a table, okay? So remember, when we make a table, that's where we pick some values for x and then we plug them into the function and simplify to get y. So let's say I pick 1 as a value for x. That means I'm going to plug 1 into my function. So this would be 1/2 times 1 minus 3 minus 2. And then simplify using order of operations. I'm going to start inside parentheses. 1 minus 3 is -2. And then half of -2 is -1. -1 minus 2 would be -3. And then because we actually already did a graph, we can double check this. So do I have the point 1, -3 on my graph? Yes. Okay. Now, when you're picking values of x to plug into a function, let's say I picked 0, there is a chance that I'm going to get some y values that aren't so nice. That's okay. So if I were to plug in 0 here, that would be 1/2 times 0 minus 3 minus 2. 0 minus 3 is -3. Half of -3 would be -1.5 or -1.5. Now, -1.5 minus 2 would be -3.5. That's not the nicest point on the graph. That's okay. That's still a point on the graph. So we didn't have that plotted here, but I could plot 0, -3.5, and that's fine. Now, if you've already graphed your function and I ask you for a table as another way to represent it, you can also just pull points from your graph. So we've got 1, -3. We also know the point 3, -2 is going to be on here, right, from our function. So that's that guy right there. We have the point 5, -1. And then we could pull from back here, we would have -1, -4. Or you could take either of these points, that's fine too. I'm looking for you to give me multiple representations for the function. Questions for me so far? Okay, let's take a look at another example. For our next example, we are starting with some information. We are starting with the information that our line goes through the point -1, 4, and that we have a slope of -2/3. Okay. So I'm going to start with the graph on this one. I've got the point -1, 4, -1, 4. And then remember, slope is rise over run. We're always running forward, but rise could be up or down. Since our slope is negative, that tells me my rise will be down. So from the point that I plotted, I'm going to go down 2 and forward 1, 2, 3. Down 2, forward 1, 2, 3. And I could reverse those directions to get points to the left. Up 2, back 1, 2, 3. And then remember, anytime I graph a function, connect my points and throw my arrows on the end. I'm going to go ahead and throw these points into my table. So I've got the point -4, 6, -1, 4, which again was given to me. I've got 2, 2, and I've got 5, 0. We're going to write our function, and then we'll get one more point for our table. So for our function here, I'm going to use point slope form. I've got a point and I've got the slope. So I'm just going to throw those things into point slope form. So I'm going to put the slope here and then my point in those HK spots. So this would be y equals -2/3, and then in parentheses, x minus -1 minus the negative would be plus. So see, it's the opposite sign in parentheses versus from my point, and then +4 at the end. There's my function in point slope form. Now I'm going to use my function to find one more ordered pair for my table. Now, again, I could pick any x value that I want, but we're going to have to multiply it by -2/3. So I want to try to pick a value that's not going to be too terrible to work with. For the values that we've got in our table already, I'm going to use the 2 and the 5 as an example here. So 2 plus 1 is 3, right? And then when I multiply my -2/3 by 3, what I'm actually doing is multiplying by 2, but dividing by 3. This ends up being a nice y value because my number here is divisible by 3. The same is true of 5. So 5 plus 1 is 6. So if I plugged in 5 for x, 5 plus 1 is 6. 6 is also divisible by 3, right? 6 divides by 3 evenly. So what I want to do here, if I can, is work smarter, not harder, okay? I want to make these numbers easy for myself if I can. So I'd like to pick an x value that I can divide by 3. So I need something that when I add 1 becomes a number that's easy to divide by 3. Mm-hmm. Yeah, 8 would work. 8 plus 1 is 9. 9 divides by 3. So I'm going to plug in 8. I'll plug it in down here where I've got a little more space. So this would be -2/3 times 8 plus 1 plus 4. 8 plus 1 is 9. And then I'm going to do the divide by 3 part first. 9 divided by 3 is 3. -2 times 3 would be -6. So then I've got -6 plus 4, which is -2. You can pick any x value that you want. Some of them are just going to give you kind of funky y's. Questions for me so far? Okay, turn the page. We're going to look at a couple more examples. On the next page, we're going to start with a table this time. The nice thing about having a table is that tables are easy to graph. So I'm going to plot the points from my table. I've got -1, 4, 1, 3, 3, 2, 5, 1, and then this is off my graph just a little bit, but 7, 0. Plot my points, connect them, and throw those arrows on the end. Now, I need to identify the slope of this line. How can I find the slope? I've got a graph. How can I find the slope? Mm-hmm. Yeah, just look for the rise over run. Count it from the graph. So from one point to the next, we have to go down 1. So that means my slope would be -1 and then over 2. So -1/2 is our slope here. And then we also want to identify a point from the graph. You can pick whichever point you want. Okay, there's nothing special about any particular one of these. If you just want to take the first one from the table, that's fine. If you want to take this one, that's fine. If you want to backtrack your slope a little bit and take this point or this point, that's fine. Any point on here will work to write point slope form. That's the nice thing about point slope, is that any point works. For slope intercept, you have to have the y-intercept. And sometimes the y-intercept is not a nice number. But for point slope, whatever point you want. That also means that when we write equations in point slope form, you may have a different equation than your neighbor. That's okay. You should have the same slope, but if you use a different point than them, you're going to have a different equation, and that's okay. So let's start with, we'll start with this point. So that's the point -1, 4. So I'm going to write my equation based on the point -1, 4. This would look like y equals -1/2 times x, opposite sign here, plus 1 plus 4. There's my equation in point slope form. If I wanted to choose a different point, let's say I picked this point instead, that's 3, 2. I could write an equation based on that point as well. Same slope, but this time I would have x minus 3 plus 2. Different equation because I based it on a different point. Both of these describe the same line. Does that make sense? Okay, questions for me. We're going to take a look at one more together. If I just scoot my paper over here. This time we're starting with a graph. There are a couple of bolded points on here, but we can see other nice points on our graph. I'm going to go ahead and do my table first. So I'm just going to take the points from my graph and throw them in my table. So I've got -5, -1. I've got, that's -3, -2, -1, -3, 1, -4, 3, -5, and then this guy here would be 5, -6. So I went outside of the table just so I could make sure you had an example of every point that we've got on our graph here. And then let's find our slope. What's our slope for this line? What's our slope? Yeah, to get from one point to the next, I have to go down 1 and forward 2. So that's the slope of -1/2. Now, I would like you to pick any point from this line and write an equation in point slope form. We have our slope, pick any point you like. you should have had one of these. So make sure that your equation is one of these. If it's not, I want you to call me over in just a minute and we'll take a look. 9 out of 10 times it's a sign error or we flip-flopped X and Y. Okay, so if you did not have one of these as your equation, call me over in just a minute and we'll figure out why and get it fixed. For the rest of class, you should be able to get it done with our class time, but if not, homework. For the rest of class, you have an assignment on delta math that's going to ask you to, again, write equations either from 2 points or from a graph. A couple notes on that delta assignment. In class, we can use f of x and y equals interchangeably. On the delta assignment, it does not like f of x. It will mark you wrong if you do f of x. So use y equals. And then all of the explanations center around finding the y-intercept. So plugging in the x and y value from a point to find the y-intercept to write it in slope-intercept form. You do not need to write it in slope-intercept form. I want you to stick with point-slope form like what we talked about today. But I just want to give you a heads up that all the explanations are going to be about how to write it in slope-intercept form. So if you miss a question and you're not sure what was wrong, use our class time to ask those questions, call me over, and I'll take a look at your problem for you. But you have to use y equals when you enter your equation for the delta math. Don't use f of x. It gets very mad. And again, those explanations aren't going to be quite what we did today, but you can still enter point slope form as your equation for your line. Does that make sense? Okay.